Ladies and gentlemen, boys and girls, welcome to another episode of Transparent Physics. In this episode, we are starting a new series on projectile motion. And as usual, before we can get into the math, we got to make sure we understand the concepts behind the math. Otherwise, we're just pushing buttons. Our goals for this lesson include defining what projectile motion actually is, reviewing the concepts that support projectile motion, and in an ideal world you'll have covered these already, but if not, we'll introduce the main ideas. And we'll visualize the two personalities of projectile motion with the help of Bill Withers and Katy Perry. Trust me, it's going to make sense. So what is a projectile? A projectile is an object that travels through the air after launch, and this launch can have a lot of different scenarios behind it. You could be tossing something into a trash can, you could kick something off of a dock into the water, you could be firing something out of a cannon, a car could be driving forward and drives off a cliff into the air. All those things qualify as projectiles, even though they might seem different from each other. One note for this particular set of lessons is that we're going to focus on projectiles that travel both in the horizontal and vertical direction simultaneously. Technically, if you throw an object straight up into the air, it's a projectile, but that's one-dimensional motion, and we've already talked about that in earlier lessons. We're going to focus on two-dimensional motion here. Same ideas, but more exciting. And also, we're going to assume that a projectile has no other force acting on it while it's in the air besides gravity acting on it. Now, that is a simplification, but if you've been taking introductory physics up to this point, you know that we do simplify our problems so that we can work them out more easily. And if you're a real-world engineer or physicist, you probably could be required to include air resistance in the calculations, but that makes things a lot more complicated. So we're not gonna. All right, for the good, the bad, and some more good. First of all, there's no new physics, which is good news. Now, really, I should have an asterisk after that. I say there's no new physics, assuming that you've already covered Newton's laws, kinematics equations, and vector math, which probably isn't a stretch because you're probably not talking about projectiles in the first week of your introductory physics course. If you haven't covered any of those topics, even more good news, Transparent Physics has lessons about all of those that you can watch. Bad news is that these problems definitely can be more complicated. When we're doing projectile motion, we are looking at horizontal and vertical motions at the same time. Probably up to this point, you've either looked at things moving horizontally or things moving vertically. So this transition to looking at both those at the same time results sometimes in a little bit of information overload. There's a lot more pieces of data to work with than you're used to from earlier in your course. But more good news, an organized approach can help keep things clearer for you moving forward. All right, time for sort of a back of the envelope review of Newton's laws of motion, and realistically speaking, it's only 2/3 of them, so it's not even all of them. The first law, also known as the law of inertia. An object that has balanced forces acting on it will continue its motion. So an object where the forces aren't winning in either direction just keeps doing what it's doing. In this particular scenario, an object that has a horizontal velocity to the right will keep that same velocity, assuming that there's no horizontal forces acting on it. And just a little bit of administrative stuff. I historically draw my projectiles starting from the left and moving towards the right. They don't have to. It's just a good convention. It simplifies the math a little bit. Newton's second law, sometimes known as the law of acceleration. An object that has unbalanced forces acting on it will accelerate in the direction of the net unbalanced force. And in this scenario, we're going to be looking at the unbalanced forces being gravity pulling down. And if gravity, aka the weight, is the only force pulling down on it, then it's automatically winning, and the acceleration is going to be directed downward as well. Okay, a quick vector math review. Velocity is a vector quantity, which means it has a magnitude and an angle and can be broken up into x and y components. So if we have an object that has an initial velocity 41.58 meters per second at 45 degrees, we can break it up into its x and y components as shown in the sketch. The x component is equal to the speed, which is the magnitude of the velocity, times the cosine of the angle with respect to the positive x-axis. Plug the numbers in, you get 29.40 meters per second. And the y component is a very similar equation, just swap out cosine for sine. At 45 degrees, sine and cosine are equal to each other, so we're going to get the same answer in both regards. Okay, now that we got the background done, it's a natural break point. You can pause the video, brew yourself a cup of tea. Maybe while you're doing it, write a list of all the sports that you can think about that rely on projectiles in order to be able to play. I would imagine it's a long list. So let me introduce what I consider to sort of be the two personalities of a projectile. And what I mean by that is a projectile's motion can be a little bit complicated. If you've got a drone with a camera on it and you fly it up above the field where you're playing with a friend and you toss a baseball to your friend, when the drone's looking down on the motion of that baseball, the motion's going to seem pretty straightforward. The baseball is just going to seem to move at a constant velocity towards your friend, and your friend hopefully catches it. From another perspective, if you set up your camera maybe 50 yards away in the field and you throw the ball to a friend and the camera is set up sort of looking straight on for you throwing it to your friend, what the camera is going to see is the ball going up, slowing down, and then coming back down, speeding up. Obviously moving closer to the camera at the same time, but it's a much more complicated motion. So we're going to take a look at these each individually, and then we're going to try to blend them together to show you how a projectile motion actually is formed. So of the two personalities associated with horizontal motion, the first personality is horizontal motion, and this is a reliably steady motion. This is because there's no forces that act on the projectile in the horizontal direction after launch, and that's important to emphasize that we're talking about after launch. All these projectiles are launched in some way with an initial force. We treat the object after that initial force is done, so that the only thing left is gravity acting on it. So if we ignore the actual push or explosion or whatever it is that gets the object moving, once it's in motion, there's no forces acting on it horizontally, and therefore, according to Newton's first law, its horizontal motion is not going to change. And if you were forced to sort of imagine that motion as a song, I can think of no better manifestation than the 1972 classic from Bill Withers, "Lean on Me." The song is a nice, simple, steady song, and the lyrics are about a friend who's always going to be there for you no matter what. You can look away, look back, you know exactly where they're going to be. And that's horizontal motion for you. So let's see if we can visualize that a little bit with some simple graphics moving forward. Looking at the second personality, it's associated with the vertical motion, and this motion is constantly changing. With gravity acting downward as the only force in play, again, after launch, the projectile is always going to be accelerating downward. And in earlier transparent physics lessons, we've talked about the idea that even though the acceleration is constant, the motion could be changing a lot. It could be speeding up while going down, it could be slowing down while going up. It could do both those in the same problem. So because things can change around so much, a great way to think about it is the 2008 breakup anthem by Katy Perry, "Hot and Cold," because you never know what's going to be going on. You look one way, what's something different now? What's going on? It's all different. Let's take a look. I mean, obviously the vertical acceleration is constant, so it's a little more predictable than maybe Katy Perry would suggest in her song, but let's run with it. It's a metaphor. It's a metaphor. So the cool thing about projectile motion is that we have two simpler motions that we understand, that steady horizontal motion and that changing vertical motion, but they occur at the same time in a projectile. Again, assuming that we're going to have a two-dimensional launch and we're not just throwing it straight up in the air. And when these motions occur at the same time in the same object, we create this classic sort of projectile motion arc. So let's see how that animated out with the two motions blending together at the same time. All right, then, I hope in the course of this lesson you've come to recognize that projectile motion, even though it looks kind of complicated when you just see an object sort of flying through the air, that you have sort of this visual scaffold now, that complicated motion is just two simpler things happening at the same time. And I say just, I should really put that in quotes. A horizontal motion is something that you can analyze, a vertical motion is something that you can analyze, and then you put those together. And sometimes when you have two simpler things happening at the same time, it's more complicated. Try watching two little kids. Watching one little kid, maybe not so bad. Watching two little kids at the same time, much more complicated. And if you had to carry one thing from this lesson forward, I would ask you to recognize the idea that each of these motions, the vertical motion and the horizontal motion, occur independent of each other. You can still use all the techniques that you used before to talk about horizontal motion. You can use the techniques you've talked about for vertical motion, but the motions themselves occur simultaneously. So you have to have a little bit of agility to blend those two things together. So kind of like two songs that are playing over each other at the same time, each song is going to do its own thing. It doesn't care that the other song is playing, but you're the one that has to sort of blend those two things together when faced with both of them coming at you at the same time. And we made it to the end of another Transparent Physics episode. If you found the content to be useful, please consider liking the video. If you have any questions about what I talked about, leave them in the comments below. And to find out what's coming next from Transparent Physics, please consider subscribing and helping the channel grow so we can reach more people with tales of Katy Perry and Bill Withers. And as always, thanks for watching. I hope I've made the somewhat complicated motion of projectile motion a little clearer for you on this lesson of Transparent Physics.